we will be covering calculus, first semester of Mr. Lung's class. We're going to be doing product rule, power rule, quotient rule, and most of the trigonometric derivations. We're going to figure out how to do derivatives of said things, which will then lead into the chain rule, and then combining all of those rules together. You know what? I'm just going to list everything right here, and then tell you the specific times at which they will occur in the video, so that you can just skip to those. Keep it nice and simple. Okay. The derivative of a function is just the slope of that function. So for example, if you have f of x equals x, I don't know how well you can see that. It looks something like that. You got the little slope. And the slope of that line is just 1, because that's the slope of the line, and it's always the same. So your derivative of that, or f prime of x, would just be 1, and that's what the graph would look like. It's a pretty basic concept. I need to find something. Ooh, sock. That's what a derivative is, and that may seem pretty simple, but what do you do when you get something like that? What is the slope at one given point of that? Okay, so you could just guess and say, oh, well, at 1 the slope is, I'm just gonna guess it's 1. But that's dumb and wrong, so you're going to get the question wrong if you do that. How you find the slope of that is by doing what we call a power rule. Yeah. Okay. Yes, I took the time to write that out. How you do the power rule is, let's say your function that you're trying to find the derivative of is f of x equals x squared, okay? So, you need to find f prime of x equals x squared dx. So that's how you would set up your function. You would put a prime on this pretty much, and then put a dx at the end, and that's kind of like, it's kind of like an algebra thing where you have to like do one to one side that you do to the other. So that's what that is, and you need to get rid of the dx. And yeah, all you would do is you would take the exponent from the x minus 1 from the exponent, and then bring the number that the exponent is down in front of the x. So you would have f prime of x equals 2x to the 1, and then that magically gets rid of the dx. Okay? And the dx means with respect to x, by the way. So, yeah, and 2x to the 1 is the same thing as just 2x. So there you have it. Okay? The derivative of some function is n times x to the n minus 1. So yeah, that right there. Yeah, that's all I have to do. And that gets a little bit more complicated. Let's say you have that. I'll probably put that on the screen or something. But take a second and try to figure it out. do, according to our n rule, you would take your exponent, which is n, minus 1 from it, which would give you 2, and bring the exponent, your original exponent, down in front. So that would give you 3 times 3x squared, okay? See how that works? Because you just take your exponent, which is 3, down in front, and then minus 1 from the exponent. So, which gives you 3 times 3 times x squared. Or just 9x squared, pretty much. So, there's your basic power rule. It helps a lot if you have taken physics before, because so much of calculus is pretty much for physics. And it all makes much more sense if you understand that kind of business. Now you might be thinking more on the power rule. This is still part of the power rule. What if you have an equation that looks like that? Okay. So, you might be thinking, well, oh crap, I'm gonna go pee myself and not do calculus anymore. But I say no, because it's very simple. All you have to do is separately do them. That's all you have to do. Okay, so don't flip out. So f prime of x would be just 2x plus 2x. Super simple, okay? That leads us on to our next thing, which actually makes a difference. And if you know this already, then stop watching and skip forward. Okay, so you have that, right? Now you might be thinking that you do the same thing as addition, but you're wrong, and that's not right, and you should continue listening. So, what this leads us on to something called the product rule. Yeah, product rule. Okay, it's a product rule because it's a product of 2 different things, by the way. So, this is not that hard either. What you're going to, what you do is you take either one of these, okay? So I'm going to pick x squared, and I'm going to find the derivative of it, okay? So x squared, the derivative of that is just 2x. So I'm going to try to write this upside down. Oh god. Okay. So you're going to take the derivative of that and put it down on your piece of paper or whatever, okay? And then you're going to times it by the regular, not derivative, just the regular, your second thing in there, which in this case is just x. I don't know what else to call it. So, you have 2x times x, okay? And then you're going to add it to, god, this is hard. You're going to add it to the regular, like just the non-derivative of the first thing that you found the derivative of in the first place. And you're going to add it to that regular thing. Oh my god, these 2's impossible. Times the derivative of the second thing. Okay. So times 1. Okay? Okay? So, another way you could put this, I'm just like, so h of x would just be x squared in the last case, and g of x would be the x, just the regular x. Okay. Like, this is the overlying rule that you need to memorize. You would do this by just saying h prime of x times g of x plus h of x times g of x. That makes, I hope that makes sense. Like, so in other terms, I'll make this as simple as possible. So your h of x would be x squared, and your g of x would just be x, right? So your h prime of x would be 2x, and then your regular g of x. So that's what your first one would be, okay? And then you add it to the other way around, pretty much. So you have x squared plus times 1, okay? So take a look at this. Pause on it if you have to, do whatever. Okay. And memorize that. Now, keep that, you have to memorize that if you want to pass calculus, pretty much. And probably do homework. Not that I do, but you know, that usually helps. That leads us on to our next thing. The quotient rule. Yay, applause, smiley face. Yeah, okay. This is another one that you have to memorize if you want to pass calculus. Or even learn calculus if you're just doing this because you're bored. It's for equations that have things like, let's say that, okay? So you have x cubed over 3x squared. Now, how would you find the derivative of that? Oh, sorry, I forgot the dx up again. How would you find the derivative of that, okay? So, it's kind of similar to the product rule in like a little bit. And there is a song that I will talk to you because I cannot sing. That it helps so much, it's amazing. Low D high minus high D low, square the bottom and away you go. It's genius, okay? So what that means is you take the low times the derivative of the high. So in this case you have 3x squared times 3x times 3x squared. I actually did not do that on purpose, but so you have low D high, and then you minus it from high D low, okay, which means high derivative of low, okay. So then you have x cubed times the derivative of your low, which would just be 6x. Okay, so it's low D high minus high D low, square the bottom, and away you go. Okay. So then you just square the bottom and away you go. You know, it's like just like that. You know. So that would be the answer right there. Okay. Okay. So look, here's where the song is awesome. Okay, look, it's quite something. Low D high minus high D low, square bottom, and away you go. Okay, so as it turns out, the derivative of sine of x is just cosine of x, or negative cosine of x, and the derivative of cosine of x is just sine of x. Pretty basic. It could be the other way around. Sine could be cosine. Sine of x could turn into cosine. And cosine of x could turn into negative sine, but I'm just too lazy to look that up right now. So I'm not going to. You can look that up on your own time. It's on Google, don't be lazy. Like me. There is also tangent of x, dx, which turns into secant squared x. Okay? So look at that chart, write it down, whatever. That's your derivatives. Okay. So, I don't know why tangent turns into secant squared x, but you know what? That's okay, because we don't judge tangent like I judge you. So, that leads us on to the more advanced derivative, which is the chain rule. Dun dun. This one gave me the most confusement. Is that a word? Yeah. Okay. This one gave me the largest amount of confusion because it is the hardest. I think the best way to explain it is still using the H and G. So, okay. So, when you have this kind of situation where you have a function inside of parentheses, pretty much, just like a more than just x function inside of a parenthesis, that's when you need to use a chain rule, okay? So when you have division, you use a quotient rule. When you have multiplication, you use a product rule. When you have anything trigonometric, you use the trig rules. And whenever you have any just like regular x squared, that's when you just use the power rule, okay? This right here, where it's 4 times x squared cubed, you have a function which is fx squared inside of a function which is 4 times, well, pretty much x cubed. That's when you need to use a chain rule, okay? What you do is you figure out what your inside rule is, which in this case is x squared, and you don't touch it, okay? You don't touch it. And you figure out what's on the outside, which is the cubed in the 4, and you derive that, okay? So what you would do in this case is you use a power rule, which is the original one, and you minus 3 from the x, or you take the 3 down in front of the 4, and times the 3 by the 4, which gives you 12, and then you minus 1 from the exponent, and then you leave the inside the same, okay? So that would give you 12 times x squared, okay? And then what you do, after you've done that, after you've found the outside crap, you take what is on the inside that you didn't touch, and you times this whole thing by the derivative of the inside, okay? Which would just give you 2x. So your final product would be 12 times x squared, no, that's fine, 12 times x squared squared times 2x, okay? My dog just comes in and chills for a second. I mean, it's kind of funny. So the overall rule for this is pretty confusing. You have to kind of, it just kind of clicks and then it's really easy, but it's hard to explain. So the overlying rule for this is would be f prime of g of x times g prime of x. Okay, this is kind of confusing. So I'll compare these two and what you have to do. Okay. So what you have is f prime of x. So what you have at the very beginning is, sorry about that, we're going to change that to h prime just to keep consistent. So what you have at the beginning is h of g of x, okay? So So your h would be the 4 and the cubed right here, okay? Then what you would do is you would find the derivative of the outside of the stuff of the 4 and the 3, which would be 12 and 2 up here by using the power rule. And then you times it, or multiply it rather, by the derivative of g of x, which is x squared, giving you g prime of x right there. Okay. Yeah, you might have to like watch that a bunch, or just like go talk to your calculus teacher and try to get a better idea of how to do it. Or you could even comment and I would try to explain it better. But I brought different pens. Oh, bought them rather. It was like $6. Okay. Let's say you have 4x squared. Okay. Now, if you think about it, when you're doing the power rule, which you would do for this one right here, you're doing the chain rule. You really are, because like, if you look at it this way, you have this 2, right? You bring it out in front, right here, and then you minus 1 from that, which would give you 8x. Now, if you think about it, this x right here, the derivative of that is just 1. So, if you times that by 1, it just gives you the same thing, and you don't have to think about it. But you are doing the chain rule. Okay. So, if you think about it that way, then it makes the other ones, I think it makes it a little bit easier. So, like, so say that you have 5x squared cubed, okay? Now pretend that that is just x. Just pretend, okay? Pretend. But then as you write it down, don't pretend anymore. You write down that it's x squared. But you bring down the 3, and then you minus 1 from this, from the exponent, okay? Which would give you 15 pretending to be x squared, okay? Now, you just leave that there, leave this how it is, and then times it by the derivative of this, okay? Which would be 2x. So, in the end, you would bring down the 3, minus 1 from that, which would give you 15 x squared squared, okay? And then, like you would up here, except you don't really have to up here because it's a power rule, you just find the derivative of that and times it by that, which is 2x. So you just add the derivative at the end. Okay? Good explanation. Good job, Dylan. Okay. So now, we're going to start combining rules. This is pretty much just being smart and seeing what rules you need to use, which is actually somewhat simple. The hardest thing about this is knowing what order you have to do it in. Okay? Really, it's not that hard. Like, I'm going to switch to blue just because I can. Let's say that you have... Let's say you have something like that, okay? 2x times x squared over x to the third. You can look at it and see what kind of overall thing it is, which in this case it is division, because it's all of this over this, over all of this. So you know it's quotient rule, and you have to use the same rules as quotient rule to begin with, which is low D high minus high D low, square the bottom, and away you go. Okay, so you still do all the same things in there. You still take the low times the derivative of the high, which you have to use a product rule to get, and then you minus the high, which is just this in itself. You don't have to find a derivative of it, times the derivative of the low. And then you just put it all over x cubed squared. Okay, so now all you have to do is you take the low, which is x cubed, times the high, the derivative of the high, which would be the product rule of 2x times x squared. So you put in a big old parentheses the derivative of your high, okay, which would be the product rule of the top. Okay, so it would be 2 times x squared plus 2x times 2x. Okay, so now you have your low d high part of the quotient rule. Okay, and you had to use a product rule to figure out the derivative of the high. Okay, and then you minus that by the derivative of the low times the regular high. So 2x times x squared, and then you take all of that, okay, take all of that, and then divide it by your low squared. Okay, so that would be your answer to that question, and you still, all you did was the quotient rule, except you had to use the product rule to do the quotient rule. Okay, now on the other side of that kind of deal, you could have a product rule overlaying, which you need to do a quotient rule to figure out. Okay, so let's say that you have x over x squared in parentheses times 2x. You would still have to do the same rules as the product rule, meaning that you would times the derivative of this by the regular of that, and then add it to the opposite, being the derivative of this and the just that. Okay. Now, there's another way that that combining rules can come. There's two more ways that combining rules can come into play. One of which is being you have to use a product rule inside of the product rule. Of course, you have to just know how to do it, and that comes with time. Unless you mean you get it instantly, because I'm totally freaking smart. Let's say you have 2x times 2x squared times 4x cubed. Okay? Let's say you have that. How would you want to do that? How would you? I don't know. Okay, so I'll tell you. This is all you have to do. Bam. All I have to do is just add parentheses. You'd find the derivative of this right here, or if you want this, or these two, I guess, if you really want to be a butt. But you'd find the derivative of any of those two numbers times each other, and then use the product rule on that. So, for example, if you use 2x times 2x squared, you find the derivative of that, which is just 2x times 4x plus 2 times 2x squared. That's your first derivative, and then you times that by that right there, which is using the product rule, because you find the derivative of that times the regular of your next number, okay? And then you add that to the derivative of your next number, which would be so you'd have 12x squared times 2x times 2x squared. It makes things a lot easier, for me at least, if you put parentheses around all of that, all of your separate equations, so that it's easier to read and know what you've done. So there's your combining rule. We have one more kind of combining rules, which is chain rule and everything else. I'll give you one example of this because this is taking a lot longer than I thought. So let's say you have this, okay? You need to find the derivative of that. It's really simple, okay? You just use the chain rule. And then when you need to find the derivative of the inner, you use the product rule. And Mr. Lund will give you some very large, like super big equations where you just have to do everything pretty much, and it is a total son of a gun to do. It'll just like, that's what your equation will look like, except it'll be numbers and it won't be a stupid line. So, I won't do any of those because they're just painful. And it's all the same. So, you do your chain rule. So, the outer is sine. So you find the derivative of the outer, which would be cosine of the inside of what it is. So it'd be cosine x squared times 2x times the derivative of x squared times 2x, which you just use the product rule, and which would give you 2x times 2x plus x squared times 2. Okay? So that would give you that kind of... Now, if this all right here, like x squared and over 3x cubed, you'd have to do a huge quotient rule using all three of those. Okay, so what you would have to do is you'd have to find the derivative. You'd have to find the derivative of all of this, which would be this big old thing right here, plus all of this right here, plus 2x times that. So you can see how this can get pretty long. Minus all of this times the derivative of this over this squared. Yeah, it gets really long though. So I'm not even gonna try to explain it. Now onto logarithmic differentiation. Okay.